So, if we have a function, how can we find the derivative of the inverse function for a given value of x? We use the formula. This is the formula, 1 over f prime of f inverse of x. So we want the derivative of f inverse of 40. So we'll have 40 here. And notice at this point that we need to find two things in order to evaluate this derivative. The derivative of f and the output from the inverse function when the input is 40. So first, f prime of x using the product rule. Second, let's find that. My advice was to look at two sets of ordered pairs, one for function f and one for function f inverse. And we need f inverse of 40. So when the input is 40, what's the output from the inverse function? Well, now we're going to take these coordinates and invert them for the inverse function here. So when 40 was the x-coordinate, now it's the y-coordinate. And what we need was the y-coordinate. Here it will be the x-coordinate. So we're going to use function f and ask what can we put into f so that we get an output of 40. So we're solving this equation. Now since this is not a calculator problem, the answer to this is going to be something very easy that doesn't require a calculator. So we need to be able to take the square root, so x has to be at least 6. So let's try x values that give us a perfect square. If x was 7, we'd have 14 times the square root of 1. Too small. So the next perfect square is 4. So if x is 10, we'd have 20 times the square root of 10 minus 6. There it is. 10 minus 6 is 4, and the square root of 4 is 2. So if x was 10, we'd have 20 times 2. X has to be 10. And that means for the inverse relation, 10 will be, instead of the input, it'll be the output. And now we can answer the question. So maybe simplify f prime a little bit. And now, f inverse prime of 40 is 1 over f prime of 10. And so when we put a 10 in there, we get this, which simplifies to 1 over 9. Choice B.